Here we go. Okay. So we're going to do this together now. Okay. We're going to do this together. So again, here, what we want to do is when you divide, remember, you have to take the second expression and flip it basically, you know, invert it, so to say. So it becomes this. And doing so, you make this into multiplication. And you end up getting this. Now, again, you could leave this in factored form. In other words, I would not actually multiply these out, at least not until you tried simplifying it, because you have to simplify it. Okay? All right. So we want to simplify this. So what can we do? Well, these are actually not hard to factor. So let's just factor everything. I mean, you could use the factor theorem if you really wanted to, but let's just factor everything. So for the denominator here, right? So everyone can hear me. Yes, okay, I just want to make sure the mic was on. So to factor it, right? For the denominator here, notice we have a trinomial, right? 3 terms, degree 2. And the leading coefficient is 1. The leading coefficient is 1, okay? Okay, so we want two numbers whose product is 20, but the sum is 21. And the sum is 21, excuse me. Well, even without this being here, you should be able to see that 20 and 1 work. They're the ones that pull that off. So 20 and 1 work, okay? So we have x plus 1 times x plus 20. Here, for x squared plus 7x plus 10, this numerator, right? Here we have, okay, we want two numbers whose product is 10 and sum is 7, right? Again, we have a trinomial, degree 2, leading coefficients 1. We want two numbers here whose product is 10, but the sum is 7, and the sum is 7. 5 and 2, right? So that's how we get this. For 2x minus 10, I mean, really here, you can't factor out x. It's degree 1, as you can see. But 2 we know is a factor of 10, so we can factor that out, and that's what we do here. And then you put this all in here, as you can see. And you can see it's actually already simplified. It's already simplified. And again, here, you don't have to multiply these out. I know it takes a while, so that's why we can leave it like this. I mean, I am going to do addition and subtraction. There I actually do multiply it out. But with multiplication and division, you don't have to. You'll see what I mean. But are there any questions on this? Okay. But as I just said, we can also add and subtract rational expressions. Now, just like, okay, just like with fractions of integers, you know, just like with fractions, you have to have a common denominator. Okay? You have to have a common denominator. So we do have to get a common denominator. Now, since we will be simplifying the LCD, which is the least common denominator, that's really the best choice. I mean, theoretically, you don't have to get that, but if you get something else, odds are you're going to have more simplifying to do. By definition, what is the least common denominator? That's the polynomial of smallest degree that such that each denominator is a factor of. So it contains each denominator as a factor. All right, now, how do you actually find the LCD? Okay, how do you actually find that? Well, basically what you're going to do is this. You have to factor each denominator completely. You do have to do that. You're going to list each of the irreducible factors, the different ones, you're going to list them, okay? You're going to list each one only once, okay? Sometimes they could be repeated. That is, sometimes you can have the same factor in two denominators. You only have to list it once. You'll see what I mean when we do examples. And they may be raised to x to powers, exponents. So get each of the, so you want to determine each factor's largest exponent among the factor denominators. And then you raise each factor to its largest exponent, and then you multiply everything together. I know that sounds kind of, like what the heck is he talking about? When we do some examples, it will make sense. So for instance, let's say we have this, right? Let's find the LCD for these two pair of rational expressions. All right, well, here it's a little bit easier. The denominators are factored already. So what are the factors, the irreducible ones? Well, we have x minus 1, right? We have x plus 2. I mean, there's an exponent here, but let's disregard it for now. And we have x, as you can see, right? So what I'm doing is I'm also listing the irreducible factors. Irreducible means you can't factor down any further, okay? Like so. X minus 1 is taken care of, and so is x plus 2. So these are the three irreducible factors. Then what we want to do is you want to determine the largest exponent that each factor is raised to. So x minus 1, here it's raised to 1, right? If it's not written, it's understood to be 1. Here it's raised to 2, so 2 is the largest exponent for x minus 1. X is not here. X is over here. It's raised to the first. So the only exponent of x is 1. We have that here. For x plus 2, we have 3. We have 1. So 3 is the largest exponent. Okay, so what is the LCD then? That's going to be x to the first times x minus 1 squared times x plus 2 cubed, like so. Which is the same as writing this. I mean, if you left the exponent 1 here, that's fine. I'm not going to take off points for that. I mean, people don't generally write it, but I'm not going to take points off if you write the 1 here. But this is our LCD. So if we were actually going to add or subtract these two, this would be that common denominator we would use. But we're not going to do that yet. All right. Are there any questions on this example? Yes.
So the exponent we're not like adding the exponents together.
No, you actually can't because the bases are different.
No, so like if we have the denominator x minus 1 and x minus 1, and we have 2, the exponent for that is 2, and then there's an exponent as 1, we wouldn't have x minus 1 to the third.
No, you don't do that.
Oh, okay.
Not for this though. So I mean,
so we're just picking the one that has the highest exponent?
Exactly.
Okay.
Okay.
All right.
Very
Thank
good.
you.
You're welcome. Good question. Okay. Good question. Okay. Any other questions? I mean, again, theoretically, you can use any common denominator when adding or subtracting. It's just with the LCD, I think is something you should be able to do, especially since if you have to simplify in the end, with the LCD, you're going to have less simplification to do. Okay. All right. Here's another example. Let's find the LCD of these two. Now notice the first denominator, right? It's not factored. Well, here we have to factor it, although it doesn't look that bad. For instance, x squared is the smallest power of x, okay? X squared, so we're going to factor it out. Right, that's what we're doing. So we put it in front. How do you get what's left over? Just like before, you have to divide. Meaning you divide into each term. So we have x squared times x to the fourth over x squared plus 3x cubed over x squared minus 4x squared over x squared. That's what we get here. Okay, like so. So now we have to factor this thing. Well, just like before, it's a trinomial, meaning there's three terms, right? Leading coefficient is 1, and the degree is 2. So we want two numbers whose product is -4 and whose sum is 3. Okay, what does that? For -1, you can see that from here. Okay. Well, now, okay, so now we put this in for, now we substitute that, we end up getting this thing factored all together as this. So with the denominators factored, we actually end up with this here. Now we can get the LCD. All right, let's do that. So we have x, right? That's an irreducible factor. You can't break x down any further. X plus 4, right? That's here. X minus 1, that's over here. I mean, the order in which I write these, it doesn't matter. Okay, that takes care of, and that takes care of the distinct irreducible factors from here. We have x from this denominator. That we wrote that down. X minus 1 is there already. X plus 6, we write that down. X plus 4 is already written down. Okay. All right. Now, for the exponents, here we have x squared. We have x to the first. So 2 is the larger exponent. X plus 4, we have 1. Here we have 5. So 5 is the larger exponent. X minus 1, we have 1 and 3. 3 is the larger exponent. And x plus 6, the only exponent's 1, so we use that. So the LCD then of these two rational expressions would be x squared times x minus 1 cubed times x plus 4 to the fifth times x plus 6 to the first. And again, to the first, we don't write 1. So yeah, question?
When we write out the LCD, does it have to go in any specific order according to the exponents? Like it has to go like in like a standard form, like from 2, 3, 4, 5?
No.
Okay, thank you.
You can go in any order you want. Okay, good question. So again, yeah, you could write the LCD, the product. You can write these in any order you want. So, all right, good question. Any other questions? Let me pause the recording.